Teardown time. This, of course, is a SIM card for cell phone. It originated with the GSM voice networks, and it allowed the phone to be identified by the network. And since then, of course, cell phones have become basically mobile computers, and I think the SIM functions become quite a bit more complicated. Let's find out. Let's take that outer plastic off and take a look at the die and pop it up. And here it is. First glance, pretty complicated actually. It looks like it's going to be a pretty high-end embedded controller. But the first thing you need to do is find the part number. Let's see. Here it is. Star Chip SCF384G. And if you do a little bit of Googling, you can find that that was a French company. And that makes sense. GSM was very much a European initiative. And it looks like eventually Star Chip got bought by a company called Safran. And doing a little more Googling, you can get a short form catalog data sheet. It tells us all we really need to know about the complexity of the chip, and it's quite good. They made a lot of models, it looks like, and this one is called the 384. And let's zoom into it. 384 kilobytes of flash, that's 128 for data, and 256K for program. 14 kilobytes of SRAM. So that's pretty comprehensive amount of data storage for what I thought was a very simple function. 25 megahertz processor, 32 bits. Surprising. Something I've never heard of before called the Cortex APS-3S. And if we pop over to that company's data sheet, we can see that's got another surprise. This isn't an ARM core, which I kind of expected because they kind of own this embedded space. Looks like a unique offering with 25 MIPS. That is about as powerful as a personal computer would have been about back in 1989. So tremendous, all in this little chip. Let's pop over the block diagram. This is the one for the 320G. I couldn't find anything in the 384, but I presume it's going to be probably pretty close, with the only real changes being the amount of memory that's on the chip. Let's see if we can sort down this block diagram and match it up with the actual die photograph. In the center, the processor, of course, 25 megahertz, so it's not going to be really fast, so you don't have to do anything called a hard macro, but you can probably just lay it out as a sea of gates. And if we look over onto the lower left there, it looks like that's the area where the processor probably exists. Probably also all the peripherals and everything sitting in that area. Let's see, there's going to be two flash areas, one for data, one for program. Given that the family of chips offered a fixed 256K for the program flash, but the variable data would make me think that the two blocks to the left are probably the data flash, 128K, 264K blocks, and the block to the right would be program. And that would imply that the block on the lower right would be the RAM. Okay, before we continue, let's strip the metal off this chip. It's actually hiding a whole bunch of the details that are below it. And now we can get a clearer view on the right-hand side. It looks like there's some fairly heavy analog functions. Let's just insert a picture for a second. Those large silver squares basically are capacitors. This whole area is undoubtedly the power supply section. The flash memory requires a higher voltage to program, so there'll be a voltage booster there. Zooming back out here, you see a whole interesting block called the security manager. That's of course a big theme of SIM cards, lots of security. And you can see it monitors the voltages and frequencies of the chip, and they do that to prevent an attack called a glitching attack, where you try to raise the voltage or modulate the frequency and get the chip into a strange state where you can then attack it and read some of the secrets in it. The only other thing I've noticed is the memory protection unit. Undoubtedly this processor only runs signed code, and that's basically a technique to prevent it from running any arbitrary code, which again could provide an attack vector for secrets. Otherwise, what it is essentially is a really decent microcontroller with lots of security things tossed onto it. And I must say, I was very surprised just how much compute power is sitting there in this little SIM.